Welcome to day 3. We're going to talk about wave phenomena. So let's get started. A wave is just a disturbance, and you've seen lots of waves, all kind of waves. And so we're going to talk about the specifics and go into the detail and explain how we can use this information. So a particle of a wave must be elastic because it's going to move from the equilibrium position, which we talked about was going to be the center of the wave, um, as the wave passes, and then it's going to return to that position after the wave has gone on past. So waves transmit energy from one location to another without transmitting the matter. Now, if you've ever been in the Gulf or in a body of water that has waves, you know that as a wave, if you are just floating there, as the wave comes by, it picks you up and lifts you up with the wave, and then it puts you back down. And so all the particles of water around you are doing the same thing. It is not moving the matter, the energy is moving, but the particles stay basically at the same spot. There's different types of periodic waves. One are pulses or vibrations, and these occur at regular time intervals, and you can predict where they are going, and the diagram on the right shows you this. Energy in a wave also depends on the energy of the vibration. So more energetic waves, if you think about waves before a storm is coming in, they're always got to have a lot more energy. They're a lot taller. The kind that people want to surf on, lots and lots of energy there if you've ever watched a surfing competition or been in a surfing competition. So that's pretty cool. Once the storm passes, we know that the Gulf goes back to its original state, which is usually pretty calm and sometimes very, very calm. There are two ways we can classify them. So there are two classes of waves, which are electromagnetic waves and mechanical waves. And then those two types can be further classified as transverse or longitudinal. And if you notice on the diagram that mechanical waves can be either transverse or longitudinal, but electromagnetic waves can only be transverse. And we'll talk about the difference between those, I think, in the next slide. Not quite the next slide. Okay, so electromagnetic waves are disturbances within an electromagnetic field, and they don't need to have particles. They are actually, the energy is disturbing the electromagnetic field. And so that is why light can travel through the vacuum of space. Okay, so mechanical waves, these are disturbances in the position of the particles or matter, and they are going to originate at a vibrating source, and they cannot travel through a vacuum. So you must have some particle with which to carry that energy, so water waves or sound waves. A transverse wave is when the particles move perpendicular to the wave, and a traveling wave is said to propagate. And you've seen this if you've ever dropped something in very still water, and you will see the waves propagate from the point of impact outwards in rings. This diagram shows you a view of a wave with all the parts labeled, so trough, crest, wavelength, amplitude, and you can see that it can be said to be going along the length of this rope or string or whatever it is. And if you've ever dealt with a jump rope, you know that you can hold the two people hold the ends, and you can make waves, and you can watch all of this thing. And the wave does seem to go from whoever is shaking it, the energy travels down the rope to the other person or the wall or whatever it's tied to. The crest is always going to be the point of maximum displacement. The trough is going to be another maximum displacement, but in the opposite direction. And then the pulse is a single crest and trough. So it's always going to be the entire wave itself, the whole range in which it's going. A longitudinal wave is going to be one that is dealing with compression and rarefaction. Compression is exactly what it sounds like, the areas where the particles are pushed closer together, and the rarefaction is the opposite of that, when the particles are pulled farther apart. And you can see, this is really good, you can see it with a Slinky very, very easily. And we'll do some activities in class and let you see these a little bit better. But this diagram shows very, very nicely. The compression is where they're close together, the rarefaction is when they are farther apart, and a single wave includes both a compression and an area of rarefaction. All electromagnetic waves are transverse waves, which we had already said before, and so it's the disturbance in the electric field which is perpendicular to the disturbance in the magnetic field. And the mechanical waves can either be transverse, like water waves, or they can be longitudinal, like sound waves. And we'll be going through all of these individually and talking about them in more depth. And that's where we're going to stop this one because I don't want them to be so long, and I will add to it in the next podcast. So I'll talk to you later.